Hey guys, welcome back for another chemistry lesson. Here we're going to talk about the simple gas laws. So there are four basic properties of a gas that we look at. That includes pressure, volume, temperature, and the amount of gas that we have, which we measure in moles. These properties are interrelated, so when one changes, it does affect the other things. And so we have what we call the simple gas laws that describe the relationships between these pairs of properties. So the first one was I'm going to say discovered by Robert Boyle. And the Boyle's law was created by Robert Boyle and Robert Hooke, which they used this J tube, which you can see pictured here, where they measured the volume of a sample of gas at different pressures. So what they did was they trapped gas up here with this little stopper, and then they put mercury here. Now, here's the volume of gas. The more mercury they added, the smaller this volume of gas was, and what this means is there's a greater pressure of the mercury pressing down on the gas because there's more of it there, right? So what they saw was an inverse relationship between volume and pressure. So an increase in one is going to cause a decrease in the other. So we can follow Boyle's law and use it if we have constant temperature and constant number of moles. So here we've got a graph that shows the pressure versus volume. If we graph pressure and volume, we get a curve. If we do pressure versus 1 over volume, it would be a straight line. But essentially, as one increases, the other decreases, so that when we multiply the two together, no matter what one is, if the other reflects it, we get a constant. So we can see here that as the volume of a gas decreases, so we go from 1 liter to half a liter, the gas molecules collide with the surrounding surfaces, the walls of the container, if you will, more frequently, which results in a greater pressure. So at 1 liter, we have 1 atmosphere. At half a liter, we have 2 atmospheres. And again, remember, we're going to have a constant value if we multiply those two together. So 1 times 1 is 1. 0.5 times 2 is 1. So applications of Boyle's law in everyday life. Scuba diving. So every 10 meters of depth that a scuba diver goes, they're going to experience approximately 1 additional atmosphere of pressure because of the weight of the water surrounding them, right? So at the surface, we're experiencing 1 atmosphere of pressure, which is what this is right now. And then as we go down 10 meters, that's an additional atmosphere, so 2 atmospheres total. Another 10 meters, another atmosphere, so 3 atmospheres total, to where here, that's what we're showing here, right? Depth of 20 meters, pressure is 3 atmospheres. That's 1 atmosphere from the air and then 2 atmospheres from the water. Okay, if a diver holds their breath and rises to the surface quickly, then you're going to have a rapid decrease in pressure back to 1 atmosphere. Because the pressure is decreasing by a factor of 3, the volume of your air will expand by a factor of 3, which can cause damage to internal organs. So if you ever scuba dive, always exhale when you are rising, because even a small rise in depth can give you a big expansion of the volume of gas in your lungs, and you can quite literally rupture your lungs if you hold your breath while rising up in the water column. So Boyle's law states that the volume of the gas is inversely proportional to the pressure. So more molecules colliding with the container in an instant increases the pressure, and that's what we get when we decrease the volume. So smaller volume, same number of molecules, they're bouncing off. It's like walking into a gym and throwing a tennis ball off the wall versus walking down a hallway and throwing a tennis ball off the wall, right? You throw the tennis ball off the wall in a gym, it bounces off the wall once. You do it with the same strength in a regular hallway, and it's going to bounce multiple times off of the wall. So think of it that way. The next simple gas law is Charles' law, which relates volume and temperature if we have a fixed number of moles of gas at a constant pressure. So when volume and temperature are related to one another, whatever one does, the other does, which is given by this equation up here at the top. So if we make these lines, so we've got 1 atmosphere, remember constant pressure, 0.25 moles, 0.5 moles, 1 mole, that we're just showing the lines for different amounts of gas, right? But it's always going to be linear, where our volume, which is our Y value, and our temperature, which is our X value, it's always linear, right? So if we take these lines and extrapolate them back, they will all meet here at what we call absolute zero, which is 0 Kelvin, or negative 273.15 degrees Celsius. We cannot measure this experimentally because all gases will condense at some point before we actually get down to absolute zero. But the important piece here is to recognize that whenever one goes up, the other goes up. And again, we're talking volume and temperature. Whenever one goes down, the other goes down. All right, so an example here is if we have a balloon in ice water and then same balloon with, so same amount of gas in boiling water. All right, so if we move a balloon from an ice water bath to a boiling water bath, the volume of the balloon is going to expand, right? Because our gas particles within the balloon are moving faster because we have an increase in temperature. So when the temperature of a gas sample increases, the particles move faster, collisions with the wall are more frequent, and the force exerted with each collision is greater. Remember, I said we have to have constant pressure. Well, in order to keep the pressure constant, we have to allow the gas to occupy a larger volume. So that sort of negates that increase in collisions and whatnot. So that's why our balloon is smaller here and larger here. And you don't have to use boiling water. Literally just fill up a balloon, put it in the freezer, bring it out and put it under warm water in the sink. And you'll see the difference. It's obvious even with a much smaller temperature difference. All right, other examples here. This is why hot air balloons work, because the gas is expanding. So we have less gas in this big old volume, which makes it less dense than air, than regular air. And then also here, we've taken a balloon and put it into liquid nitrogen. So you see it's shriveling up because of the much smaller or much lower temperature. So Charles' law states that the volume of a gas is directly proportional to the absolute temperature. So, according to kinetic molecular theory, increased temperature increases the average speed of the gas, which increases the average kinetic energy of the particles, right? The greater volume spreads these collisions out over a greater surface area, so our pressure doesn't change. Okay? So, we have Boyle's law, which was relating pressure and volume. We now have Charles' law, which relates temperature and volume. And then finally, we've got Avogadro's law, which relates the volume and the number of moles. So, just like the other gas laws, we are assuming a constant pressure and temperature, because those are the two things that this gas law does not look at, right? So, our volume is directly proportional to the number of gas molecules. More gas molecules, more volume. Right? We count the number of gas molecules by moles. We don't actually look at molecules, but it's the same thing, right? And equal moles of gases contain equal numbers of molecules. The identity of the gas does not actually matter here. We're talking about number of particles. So 1 mole is 1 mole, no matter what we're talking about. Right? So when a sample of gas, when we increase the amount of the gas, the volume has to increase in order for us to not have a change in the temperature and the pressure. Just like with the previous law, with Charles' law, we had to have an increase in volume because otherwise my pressure was going to change. Well, the whole point is we're holding the pressure constant. So we want to avoid that. And as you can see here, we have a linear relationship. When one goes up, the other goes up. Number of moles versus volume. And likewise, when one goes down, the other goes down. So Avogadro's law states that the volume of a gas is proportional to the number of gas molecules. So more gas molecules would increase the pressure if our volume did not change. So that is where this relationship comes from. And that is it about the simple gas laws.